All right.
Is that getting cut?
Nothing gets cut. See, every single video that I post is the director's cut. It's raw, it's unfiltered. So, what we want to talk about is how we make the transition from a logarithmic equation back to an exponential one. Now, we've already kind of seen this before, and we saw how the logarithms actually came from this equation right here. I do this silly little thing called flying the plane. I know, it's silly. I have no pilot's license whatsoever.
It's illegal too.
I'm not, hey, don't talk about legality. This is going to go on YouTube. It's a good thing I did not designate this as being for children. This is your base, right? We said the answer to the log is what? The answer to the log is the power. So A to the, there's your power right there, is supposed to equal what's on the inside. So you're going to see me draw this arrow here. For some reason I think of this as I'm flying a plane. Like, I don't, huh? Thank you, exactly. Like you're Snoopy and you're fighting the Red Baron, or is he the Red Baron? I don't even know. So you fly, you make the loop-de-loop, and you come back to this guy. So look, A to the Y equals X. Now, we did stuff kind of like this when I would say, what is log base 9 of 27? Now, we could do the change of base and knock this out pretty quickly. We could also write an exponential equation. But if I set this to be equal to X, I want you to see how we go to that exponential equation and how that leads to a lot of other good stuff for us. Your base is 9. Start with your base. You'd say 9, fly the plane, to the X equals 27. So you can rewrite this to say what we just described, 9 to the X equals 27. I mean, this is one way of doing it. Again, you could use the change of base theorem. What's the common base for these two expressions? The common base is 3, so this is 3 squared to the X equals 27, which is 3 to the 3. Remember, you have powers to powers, so what do we do with these guys? You multiply them. So we get 3 to the 2x equals 3 to the third. And then from here, what can we say now that we have the same base? We can set those powers equal to each other, so 2x equals 3, which means x equals what? X equals 3 halves. That is us solving this logarithmic equation. Now, again, we didn't have to do it that specific way. But this now lets us solve slightly more complicated questions. So if I say, what is log base 5 of 2x minus 7 equal to 2? Here's my equation. Notice that x is inside the logarithm. And I can't just like move things outside of the logarithm. What I can do, though, is I can rewrite this as an exponential equation and see if that helps me out. So your base is 5. Fly the plane, 5 squared equals what was inside the logarithm, 2x minus 7. So let's write that. 5 squared equals 2x minus 7. Look at where your x is now. Your x is not inside of a logarithm. Your x is not in a power. It's just out and about. Nice and free. Yeah. See, this is so good. I can take a nap after this.
So you just have to square 5 out of 7 divided by 2.
Right, so 5 squared is 25. You have a nice linear equation. Follow those steps that you've been doing since you were probably still in diapers. You add the 7. You divide both sides by 2. And now you get your x totally by itself. X is equal to 16. And that's it. How would you like to see a question like that on your test? Woo! That'd be swell, Mr. Craig!
The fifth root of 32 is 2.
Yes.
So if you
I'm not sure why you're talking about the fifth root of 32 here. That does not apply.
Oh, never mind. It wasn't.
You got to be careful where your numbers are. I'd hate for you to have one number in your head and then write the wrong number down. Let's see another one. If I do log base 4 of x is equal to 3/2. Again, x is inside your logarithm. So how do you think I can break this guy out or rewrite this in a way that's more useful?
4 to the 3/2.
4 to 3/2, so that's your power, equals what's on the inside. So on your test, I'm looking to see if you can make that correct transition from the logarithmic form into an exponential form. So 4 to the 3/2 equals x. Look at that. You already have x by itself. Now, can you just box this and say, I'm done? No, why not?
You have an exponent.
Well, you just need to evaluate that, right? So what does that mean? What does it mean to be 4 to the 3/2 power? How do I rewrite that?
4 to the 3rd, I have no idea.
What does it mean when you have a power that's a fraction? What? Oh, excuse you, or bless you. The denominator of your power is your what?
Is your
Index, right? We just saw some of those problems earlier today when we were dealing with logarithms. So your denominator is 2, which means you're dealing with the square root of 4, which is then going to be raised to the 3rd power. Now, for me, I think it's easier to take the radical first before you raise to the power. All right, so square root of 4 is 2. So 2 to the 3rd means that x equals 8.
bottom term
The denominator of your power is the index of your radical. See, could I write 4 to the 3rd? Of course I can. But I can't write 4 to the blank over 2, right? Fractions can never have an empty numerator. But their denominator can appear empty. That just means it's a 1. If I do log base x of 8 equals 3 to the 7th. Oh, excuse me, 3 over 7. Words are hard.
Do your airplane.
You do your, yeah, I do the airplane. So your base is x. Always start with your base. X to the 3 over 7, that's your power, is going to equal the result 8. So x to the 3/7 equals 8. We saw these equations a long, long time ago. How do I undo powers that are fractions?
7th root, because it's your index.
Well, this does mean 7th root, but that's not going to help me get x by itself. That's just going to be rewriting this side.
But what do you got to do with
How do I undo that power of 3 over 7?
it to its reciprocal?
Raise both sides to the reciprocal power. So I'm going to raise this to the 7/3 power, because you have a power to a power, you would multiply those guys. And if you're multiplying times the reciprocal, that's going to give you a power of 1, which is what we want. And of course, you do the same thing to the other side. You do that as 8 to the 7/3 power. On the left, you just have x. On the right, start working this out. How do I rewrite 8 to the 7/3?
Third root of 8 to the 7th.
The cube root of 8 raised to the 7th power. You're not going to want to deal with 8 to the 7th power. This is going to be on a part of your exam where you can only use a 4-function calculator, so make things nice and easy. What do you know better? The cube root of 8 or 8 to the 7th? You know the cube root of 8. So x is equal to the cube root of 8, 2, raised to the 7th. If you know your powers of 2, you don't have to start from the very beginning. So some of you may already know that 2 to the 5th power is 32. So I just need to build from here. 2 to the 6th is times another 2, that's 64. 2 to the 7th is multiplying that times yet another factor of 2 to get what? 128. Cool. So So x equals 128.